So welcome everybody to the second WasmEdge community meeting. We'd like to discuss a couple of topics with you today. So we're going to work through those. I'm going to kick off first by actually sharing my screen with you. And we're going to do something pretty cool. We're going to run JavaScript inside the WasmEdge runtime. So I think we just go ahead and kick it off. Okay, can everybody see that okay?
Yeah, that's correct.
Okay, cool. Yeah, so in this talk, we're going to look at running JavaScript in WebAssembly using WasmEdge runtime. Just a quick word about WebAssembly. Many of you will already know, aside from being used in the browser, WebAssembly is now considered a universal runtime for cloud native applications. It's picking up a lot of popularity and a lot of use there. So the common use cases for WebAssembly runtimes include runtimes for serverless functions, so that the fast-lock function as a service, runtimes for sidecar applications in a service mesh. We saw like the Dapper work, the demos that we've done there recently, sandboxed runtimes for edge devices and obviously IoT and things like that. So much, much more. Just a really quick word about JavaScript. And as we know, in the context of the web, WebAssembly runs side by side with JavaScript, so they're complementary. And we saw, even from the early days, like the first WebAssembly summit, that there's a very strong focus on WebAssembly and JavaScript coexisting and being complementary. So that's important to understand. And we also know that JavaScript can be used on both the front end and the back end. And so we've seen a lot of client-side implementations, a lot of JavaScript WebAssembly, and then moved over. There's a lot of opportunities for server-side WebAssembly and JavaScript and Node.js, like our function of it as a service is actually, essentially via Node.js and then going through and executing WebAssembly and then passing back the results. So the one thing that we have to realize is that not everyone will want to use, say, like C++ or Rust, especially if they've had not much exposure to that prior to coming to WebAssembly. And so developers will more than likely know JavaScript or want to use JavaScript. And this is in the context of the application logic. So we're not just talking about front-end design, we're actually talking about writing the program and creating the business logic side of things. So as we say here, JavaScript is extremely popular, and especially when programming for the web. And so I think it's fair to say that when developing cloud native applications, there's going to be a large cohort that's going to want to use JavaScript, which is fair enough. We'll demonstrate how to use JavaScript to drive the backend or to build the business end of it. So today we're going to use WasmEdge as your high performance, secure, extensible, easy to deploy and OCI compliant JavaScript runtime. Essentially, we're talking about taking advantage of WebAssembly's computational efficiency to run your JavaScript code. So a little word about the WasmEdge runtime. So WasmEdge is the leading cloud native WebAssembly runtime hosted by the Cloud Native Computing Foundation, CNCF. It's the fastest WebAssembly runtime in the market today. And WasmEdge supports all standard WebAssembly extensions as well as proprietary extensions. So we've been working on things like TensorFlow inference. We've got key value stores, image processing, things like that. It's compiler and tools chain support not only WebAssembly languages like C and C++ and Rust and Swift and so on, but it supports regular JavaScript. Probably the best way to get started with this and have a quick demo is to head over to GitHub and then to the WasmEdge repository. And we want to check out this code here. So github.com/WasmEdge, and then there is the WasmEdge repository. And if we check that out, and then we go into the directory, so tools, and then WasmEdge, and then examples, and then inside there's a JavaScript directory called JS. So as you see there on the screen, we basically just go into there, and then we're going to run this command, which is WasmEdge, and then we're actually passing in, you can see that the QJS.wasm, and so that's the JavaScript. It is essentially, compiled to WASM, and then we're actually running the hello.js file against that. So that's being executed inside the WasmEdge runtime. Now the hello.js is very simply just passing back the string that you pass in. So it'll return the result hello 1 2 3, but that's actually being executed inside JavaScript as a WASM interpretation. So that's a really cool demo and a nice simple one to kick off with if you wanted to try that. So a quick note about QuickJS. So QuickJS is essentially smaller than V8, and therefore we can run a lot more QuickJS functions than V8 functions on a single machine. WasmEdge allows the QuickJS application to use extension modules. So we just talked about things like TensorFlow, and we've got some great examples coming up of like server-side, client-side, socket work, things like that. So it opens up some possibilities to have some extension modules that otherwise wouldn't be possible. We talk about WasmEdge being the fastest WebAssembly runtime today, and this is due to its ahead of time compiler optimization. So WasmEdge provides a utility to compile your WASM file to actually a dynamic library, so a .so file instead of WASM, and this gets obviously much faster performance. So there's a few reasons, it swings and roundabouts, but there's a few reasons why QuickJS is a good choice for doing this, for running your JavaScript and executing your business logic on your cloud native applications. So I have here, I've got some links. So in these examples, we're using the JavaScript compiled to WASM. Now you can build your own QuickJS WASM. There's also, obviously with the extension, you've got the QuickJS TensorFlow WASM. Just waiting for my screen to update because, there we go. So these files already exist. So if you're in the WasmEdge/tools WasmEdge examples.js, you'll see there the QJS WASM and QJS_TF WASM. So it's really easy for you to just go ahead and pop into there and run the examples like we've shown. All you'll need to do is install WasmEdge, which is, as you may already know, just a single line command will install, and you can do that with all extensions and so forth. So that's great. So you can build your own QuickJS TensorFlow WASM from the WasmEdge QuickJS project. So that can happen, or you can just use our pre-made ones there. So just a quick note on this ahead of time optimization. So building your own ahead of time compile, like so this native shared library, this .so file, you're actually passing in the WASM file and you're getting back out the ahead of time optimized file. You can do that via this WasmEdge C command. So if you have a look there, the WasmEdge QuickJS project, you can see how to do that. And to give you an example of the difference between running just the produced.wasm file from your, say, like from your Rust compiler or what have you, as opposed to actually feeding that in and then creating this native shared library file, is something like this image example here. We have a picture of food, in this case, it's a hot dog. We're passing that in, we're running that on the WasmEdge runtime, and we're looking at around about 2 seconds execution time to perform that TensorFlow task. And when we in turn run the .so file, which is the bottom example, we see that that time is reduced down to about 0.1 of a second. So it's a very big difference, 0.1 versus 2 seconds or more. So it is well worth it if you wanted to do that for performance reasons. Now, obviously, portability across different operating systems and different hardware and things like that is something that you'd want to consider, because creating that native that native library on disk on, say, like an Ubuntu system, that's not actually going to be portable across to other systems. So that's just something to consider if you're going to use that. So the important thing to note here is that this is all written in JavaScript. So the TensorFlow functions that we've done in the past, we've gone and basically performed that 100% in Rust. We've gone and created a project in Rust and written the Rust code to load in the TensorFlow on the system and do all the image processing and box drawing and labeling and things like that. So you'll see here that this specific example of running JavaScript on WasmEdge is actually 100% JavaScript. So you've got here a very, very manageable, simple file, just sort of emulating the Rust in a way, because if you look at them just side by side, they're performing a very similar process. So that's important to note, that you can see here that this code written in JavaScript can perform this image classification task without really needing to go outside of just knowing JavaScript, which is fantastic. So JavaScript in Cloud Native WebAssembly is still an emerging area, and this is sort of like the next generation of you know, cloud and edge computing infrastructure. So we're literally just getting started, and you know, just getting warmed up. So there's many awesome use cases for this, and we'd love to hear from you, the community, in terms of new ideas. Please reach out to us if you have ideas, or if you have any issues, or you want to get involved, any sort of applications that you want to build. We can lay down some really good foundations for you. If you're interested, you can join us in the WasmEdge project, and also communicate with us, you know, feature requests, not only issues, but if you've got ideas for new things that you'd like implemented or things that you'd like to try, we can certainly help you out with that. So if you'd like to learn more about this, you can go to this article section. So we have secondstate.io/articles, and you'll see a lot of things there listed. And so that's a really handy place to go. I'm just waiting for my screen to catch up as well. It's a bit laggy. So just run over a couple of things. So the TensorFlow inference is not the only thing. We do TensorFlow Lite, of course. The network sockets are really interesting. We're able to give, you know, network functionality there, which is a huge bonus. And the other things are that we have ES6 module support. So the WasmEdge QuickJS runtime supports these modules. And so please go ahead and check that out. And also we have just a bit of code here, I think, coming up, which is showing that the support for network socket extensions here. So we have an example of like a JavaScript with it's actually port 8000, I see. It says there's server listening on port 3000. But that's an example of some nice async code to have a server-side application there. And then we also can see that it's really simple to do network client. So, you know, gets and posts and things like that. You can just write a couple of lines of code and perform that. So that's a big plus. To find out more, secondstate.io. There's a lot of information there. There's a blog. There's the function as a service work, which is really useful. You can go through that. There's the WasmEdge link, which will take you off to that. And that is wasmedge.org is the WasmEdge runtime homepage. So there's tutorials, obviously links to the GitHub, and there's a bunch of useful features and demonstrations and use cases and things like that. So you'll see a scrolling banner with some cool examples and latest releases and things like that. So feel free to go ahead and check that out. And if you've got any questions, possibly the best place to go would be GitHub issues. So for features and issues and for conversations, that would be great. So both Second State and WasmEdge organizations on GitHub, and then within those you've got the relevant projects, one of which Heide is going to run over with us. I've been testing it out this week, that what he's about to demonstrate, so it's pretty exciting. And I'm going to just pause sharing my screen, and then we're going to get ready to hand over to Heide for the next talk.
Tim, I just want to know, will these slides also be shared?
Yeah, we'll put those in the link in the descriptions when we post this. Is that what you meant? The links to the
links to the slide.
Yeah. Oh, sure. The slides. Yeah, of course. Yeah. No problems. All right, let's go out of that. Okay. All right, Heide, you're ready to go ahead with your talk on the C-RunW?
Sure. But
okay.
First of all, I think I need the permission to share the screen.
Okay. Okay, that's it. Got it there?
Okay, and can you see my screen?
Yes, perfect.
Okay, great. So let's start. I want to show you guys that how we integrate our WasmEdge runtime into the C-Run, which is OCI container runtime. And in this demo, we will show how to use CIO and Kubernetes to run a Watson application in a container. So the first thing is that how Docker works. Actually, when in the normal case, we will use the Docker command to run a service. For example, when we use the Docker run nginx, we will start a HTTP server. And the details is that when we type the command, the Docker will will send the request to the container D, and then it will dispatch to the container D thing, and then to the run C, which is also a container runtime. Then finally, you will compose your container instance, then run your service. Okay, so how to pass our WasmEdge into this workflow? Actually, we just follow the standard of the OCI spec, which is the CIO is just like Docker alternative software, and C-run is just the same thing in as this run C, just different implementation, but the role are the same. Okay, so to integrate the WasmEdge into CIO, we just need to put our WasmEdge as a library with the C-run plugin. Then when the CIO just receive the request from the user, if we want to run a normal OCI images just like the nginx, then the request will post to the C-run-W and then dispatch to the original C-run program. It just creates the normal container and then run your service. But if your image is just composed by the Watson program, then it will dispatch your request to our WasmEdge plugin, and then you will start your WasmEdge application with our engine. So we've implemented this plugin, then we can just follow the same workflow to interact with users. Okay, so that's how we integrate our WasmEdge with the CIO. And to integrate with Kubernetes is pretty simple because Kubernetes suppose not only Docker, also the CIO. So we just need to make sure that our this part from the CIO to the end is working, and then just set the endpoint to the Kubernetes runtime, and then it will make the workflow smoothly. Okay, so in this slide, I will talk about how to set up your CIO and how to set up your Kubernetes, and then create Watson images. Finally, you can run it. So everything is in this link. Yeah, I have no idea if you have tried the Kubernetes or the CIO, but the setup part is pretty complicated. So you will see lots of instructions here. Just like you will need to install several dependency, and then you will need to download the CIO binary, and then just lots of setup. Then the only thing you need to do is change the configuration. For example, you will need to change the default runtime from run C to the C-run-W, and then just set up the runtime path and the C-run-W name here to make the CIO to get the correct runtime. Then you will need to restart your CIO. That's all. Okay, so after you do these things, then you can use the CLI/CTL, this command to, to create your application and then run it. So I will show you how to run the Watson application here. Okay. Before we start, we will need to go to this one. Okay. So after you set up, you can use the CLI/CTL to make sure that, sorry, CLI/CTL. Okay, to make sure that your cell is working and your CIL is working, then you will need to provide a container configure. It's very complicated, but actually it just the most part is to set the image, which one is your image. For example, here is a Watson example, and then the arguments. This one is your Watson program name, and this one is your arguments. If you have many arguments, just put it here. For example, A, comma B, comma C. Yeah. Okay, so we will need this configuration. Also, you will need another configuration to sell the sandbox. One is for the parts and the other is for the container itself. Okay. So after you have these two configuration file, then you can just start to run your application. First thing is that you need to create the CIL part. So let me go to here, the create CIL part, this one. Okay, then here is your CIL part. You can use CI/CTL parts to show this one is this one. Okay, then you will need to just save this one, and then you will create your container with your parts ID and your container file and your sandbox configuration file. So here, this one. Sorry. Oh, the ID is 16. So I think we should, change the name. Nice one. Sandbox. Okay, let's try again. This one. This one. Oops. Sorry. Let me check. The ID is not listed. I use the wrong ID. Let me remove the original one and CO parts. Okay, so let's go back again. Parts. Okay, and then create this one. Oops. Create the sandbox was stuck. So well, so I see that we just fix it for a moment, and we just well, oops. And then we figure out later. I just just go through the next step. Yeah.
Sure.
I screen stuff here.
Yeah, that's okay. I've actually worked through this demo and it does work. So
yeah,
I've gotten right to the end.
I think maybe I copied the wrong file.
Sure.
That's
okay.
But,
yeah.
So we just go through that. So if everything is okay, we just assume it's just working, and then you can after you start after you create a container, you will get a container ID here, and then you will need to use the controller to start a container, and then you will find just I just want to show that is you can find your container is running and is it, and finally you can receive your logs from these container logs. For example, in this demo, you will just interactive with the system code, so you can get a random number, you can get a random bytes, and you can get your environment. Also, you could create your file and rewrite your file. Yeah.
Right.
So that's the first part. And this second part is more complicated because you will need to set up the Kubernetes. And so I think you will be 3 steps. The first thing is you just need to make sure that your CIO is working with C1W, and then you will need to install the Go version. At least this version. Otherwise, the Kubernetes will report a compilation error, and then you will need to install the etcd, which is the Kubernetes backend, and so you need to install all of this thing, then use this command to start the local Kubernetes node with the CIO. I won't show you this step because this command will need to, I think you will need to 10 or 20 minutes to setting up. So here, I just started an hour ago, and looks like it's still running. So we can check if it's still running. So just need to use this command to check the cluster. I need to cd into here. Okay. Oh, sure. The cluster is running. So after you do lots of things, then you will get a total Kubernetes, and use this following command to interact with your node. So we will show how to use the kube controller to run our Ascend demo. So I think this will working. Yeah, let's do it. And the following command is that this controller will run, and after it exists, it will removed, and we won't restart it anymore. And here is the alias name, and image is the same image, and your program name and your arguments. So it should work, please. Oh, great, it's working. Yeah, so we can run it multiple times, because the process is that you will create a pod called the WasmEdge demo, and then you will start your WasmEdge container with your images, also plus your command and your arguments. Then you will run it and then show the outputs. If you can also just remove the RM option, then it will still run, but it will not delete by itself. You need to delete it by your own self. So in this situation, you can find that the parts here, it will not removed, and you can, I think you can use logs to check logs. Sorry. This one is removed, and I think it's another one. Show logs. This one? No. Is this still live? Maybe I lost some options. I will also check it later. But you can use logs to show your content logs. Maybe I just use wrong command, but you know, just use the sensing to MP. I forgot to remove it. I just forgot it. Sorry. Yeah. So up to here is our show demo to run our Watson program, and I will jump into how to create a Watson here to create a Watson image. Actually, is pretty simple. You can just skip all of this because this part is we use Rust to write a program and then compile it into Watson bytecode. But you can use any language you want. For example, you can use C++ and using the EN-Scripton to compile your C++ application into Watson. Or you can use the Go compiler to compile your Go application into Watson. That's fine. After you compile you get the compiled Watson file, you will need to add the executable permission on it, and then create a very simple doc file from scratch, and just add your Watson here, and with the command here, put the same Watson name. That's all. With this, you can use doc build your doc file, and then you will create a standard OCI images. You just need to push it to the doc hub, and then you can pull it from anywhere. Yeah. So I think create a Watson application image is pretty simple. Just just copy your Watson file. That's all. Yeah. So
excellent.
So that's our our online demo here, and yeah, last mistake. Maybe I just used the wrong option, but we are pretty sure that it is work. Yeah.
yeah. No, thanks, Heide. That's excellent. I've personally gone through that demo all the way to the end, and it does work. But I think I've actually got a couple of questions. If you so when you're creating you're essentially creating an OCI compliant Docker image, and you're pushing that up to your personal account, and then when you execute it, it's actually using that. So if you wanted to change the logic in the WebAssembly, you would recompile that, like you say, using EN-Script and using C++, or you could just use Rust and the Rust WasmC tool. So once you have a brand new Wasm file, you then create, so you're replacing that Docker image and then you're pushing it. Is that correct? So if you want to change the logic, you're redoing those steps for the Docker?
Yes.
Okay, because I want to change. I see the status there is interesting. The one that was failing, its status was not ready. And what I found is when I do it, the issue that I ran into was if something executes and then finishes, I wanted to keep something alive. So I'm thinking of redoing another WebAssembly file which actually stays alive for longer so that I can interact with it, because they run so fast and then they finish. I'm just wondering whether that was an issue there, because it said not ready, whether there's some initialization with the at the container rather than anything else. I don't know.
Actually, I think this will be investigated because when we start a new Watson application in this situation, if the path didn't have any container ready, then it will show not ready later. But when we just start a container, then it will change its state from not ready to ready. So maybe there is something we need to handle. For example, the life cycle or something that will for example, because our Watson container, the initial state is created, is not running. Yeah, but I believe most of the service you will just jump into the running, not still at the create step. So maybe this is a potential issue or something. Yeah.
Yeah, no, really cool. That's awesome demo. And another thing we might try and do, and anyone in the community or anyone listening or watching this post-production would maybe be interested in looking at tidying up the scripts a bit. So I think perhaps what we might be able to do is with that installation process, because I've gone through that a few times, like I create a fresh machine to give it another go, and you do have to go through those steps. And I think maybe we could create an install script there that would be really handy. And then also when you're running down below and you run a command and you get a key back, I wonder if we can actually just feed those into the next command and try and make that a lot quicker, so we can speed up that round trip, like that develop deploy. I don't know if that's of interest, maybe to just script that part of it, because there's always the old cut and paste issues are passing in keys and things. It might sometimes leaves a bit off the end, or it depends where your clipboard stops when you quickly paste things. So just food for thought, we could maybe automate a bit of that stuff, make R&D a bit better. That was great. All right, so we have a few participants online. Has anybody at this point got any questions about anything, ideas, or
can I ask a quick question? This is June speaking.
Oh, hey,
First time joining this meeting. So thanks for the great demo, Huyen Ye. And so a question for you is, what's the difference from your component you build with the one called container d-wasm and container d-wasm container d-shim-wasm? I'm not sure whether you're aware of two open source initiative I mentioned. So my understanding is like the stuff you build is just to make it work with your WasmEdge runtime, right? But the other tools are built for the other runtime, like WasmTime and Wasm. Am I correct?
Yes. So I think the first question is, yes, we found that is a container D wasn't seen or something like that, and because we we just choose a project that the C run is write by C, so we just choose a familiar language project to to integrate our plugin into it. So that's why we not follow the container D scene, something like that, to do our integration. So
I see. So, maybe I should have phrased it this way. So your component can only work with the WasmEdge runtime. If I plug this with WasmTime or WasmMer, probably it doesn't work. Am I correct?
I think it will not work because that we just put our WasmEdge plugin with our own C API, and our WasmEdge project is not the Wasm C API proposal is just working in progress. So I think we have the different API if we want to switch to runtime. But once the Wasm C API is finished and we rewrite our C1W with the Wasm C API, then I think it will be changeable to to the Wasmer or Runtime because they have the same interface. Yeah.
Sure.
But for currently, it just can't. Yeah.
Another question is like, people when they integrate stuff with Kubernetes, mainly to leverage the orchestration capabilities offered by Kubernetes, right? So in your case, I noticed we are able to deploy the pod. You showcased that. Can we actually scaling up and down with the Wasm for those Wasm pod, or just for now just able to deploy it?
I think for now it's just for deploy, and we are still working on the the scale part. Yeah.
I see. Last question. Sorry.
No, go for it.
Yeah, there's another tool called Crosslate which we tried before. I mean, why don't you guys leverage that existing one, or you have to? Why you come up with a new tool? Yeah, Crosslate is. I think it's about. Yeah, go ahead.
Yeah, so we're doing a demo with Crosslate at the moment, and that's very soon to be released. So we are actually looking into that. It's very interesting. Yeah. So
okay.
I've got a demo and a video and a bunch of things which are ready for production, to get rolled out and written up. So yeah, we're very much looking at that. We're also looking at the difference between all the different APIs between the different runtimes, so that we can actually come up with. We're looking at a bunch of. We've got like Wasm Cloud and WasmX, and we're trying to like have a look at all of those side by side and see from an interface perspective what we need to, if there's any features that we have over and above those, like I guess the ahead of time compiling would be one, and then there's the way that the WebAssembly is instantiated and the way that things are run and the return types. There's a few little nuances. We're kind of going to look at everything side by side and see the common ground or where there's gaps and things like that, so that we can conform. So yeah, these are all excellent questions. Thank you for them. It's exactly what we want, because this is precisely what we're working on, and Crosslate is one of them. Yeah, so I've spent about a week working with that, and yeah, getting right into that, and that makes a lot of sense. Like actually to use that in conjunction with WebAssembly. Yeah, with our WasmEdge.
Last one. If I want to apply your work into our commercial product, any concern? Because the second state, you contributed the runtime stuff to the CNCF, which is supposed to be open source, right? So in this case, if I apply your work into our commercial product, still any concern or license thing? Yeah,
so just on the surface, I don't see any issues, as far as this is open source software. So we would be very happy to work with you, though. I would say that talking to Michael, who's unfortunately just traveling today, specifically got a patch of travel during this call, so I was unable to make it. But I talked to him earlier today, and we're working to try and get this to the level where we can collaborate. And so we're looking at a lot of the different products and the different runtimes and ways to apply this in commercial settings, in every way, because there's so many different opportunities. So I'd say we'd be very happy to work with you and very happy to help and share and collaborate, and that would be brilliant. That's precisely why we're doing this and giving it so much exposure and making it open source and making it community driven. And yeah, so that's ideal, I think. So that would be great if you could keep in touch with us and primarily talk to Michael and start that conversation about how you could use it and what that would look like. Yeah.
Okay, cool. Thanks, Tim, and for your great presentation, demos again.
Yeah. Thanks for your questions. Appreciate it.
Hi Tim, is it fine if I can take up the, so yeah, basically if you recall, like in the last month's call that we had, I had briefly discussed on potential use of TensorFlow.js or adding TensorFlow.js as an extension as well to the currently supported TF and the TF Lite. So just wanted to like basically ask like if how can we proceed basically with it? Is if you could probably just give some kind of steps that I can probably take up from my end as well, and then should I put it up as a GitHub issue on the WasmEdge repository? What should be the ideal steps that we can take?
Yeah, I think if you wanted to put it up as an issue in GitHub, that would be ideal, and even create an issue per like specific question or task. That would be ideal. Again, like being open source and having these conversations just in GitHub, indexable by search engines and things like that is excellent, because people are gonna find it, in that way. And anything like error messages, just try and put as much stuff in there as you can. Clipboard versus screenshots, for example, so that you're getting it indexed and people are able to discover it. But also for us to help you, I think just make it, if you make the tickets fairly small, as in specific, with a specific goal in mind, or a specific issue or an error, that'd be excellent. And then just separate them out, because having more issues, it's just a number, and it's probably easier to digest because we can separate them out and pass them on to different people in the community or the team. So that'd be fine. And how's it going? Because I haven't spoken to you since the last call. So
yeah,
how's it working?
Yeah, so basically what I did from my end was just research a bit more into the QuickJS implementation, and just look at more briefly, or sort of having a deeper dive into the current extensions that are supported. And on the side of basically on the TensorFlow.js side, I went through the Wasm backend that we are running currently. So I believe that that is where I just need some amount of help in what should be the right direction. So I mean, of course, we'll have to write some system level program to support the TFJS embeddings. So that was what, and like, would you ideally suggest going with the Node.js route, basically being able to actually create something along those lines? Because as we discussed, that probably having a Node version of the TFJS support might be better because of the just-in-time compilation. So yeah, I mean, that is something, some of the research that I was doing, essentially to sort of look at what is the best sort of implementation that we can have to support it.
Sure. So what I've done previously is, so we've got the, go to the official TensorFlow site, and if you just install that as a library on the system. So let's just say like Ubuntu 20, you go and install that, and you put it, put the libraries in the correct position so that the system can find it. We have the capability currently for it's called WasmEdge extensions. And if you install that in Node.js, what that enables you to do is write WebAssembly where you're requesting TensorFlow Lite, TensorFlow functions. And what it'll actually do is it'll step out, the runtime will step out and use the system library and return. So we have that currently in our function as a service system. There's a few demos online, image classification and object detection and things like that. So that was using Node.js and the WasmEdge extensions tool. That's had some pretty significant upgrades in the past few weeks. And I've probably about a month ago, we've updated that on the function as a service side, and it works really well. So I've tested that out since then. There was a few changes made and a few version point upgrades until the latest. So I can show you how that works, maybe another time or in another conversation, or maybe just point you to documentation in a GitHub issue. Because you can try this out. If you just actually want to do it in Node.js, you can actually instantiate like a WasmEdge instance. You can put in the Wasm file, and you can also AOT compile it. And then you can just have an image stored locally. So say, for example, we're going to do image classification or something. So you would actually just call the WasmEdge runtime in a Node.js file just on disk with an image right next to it, and it'll go ahead and give you back the results. So I've got actually a few examples that I've built just off the top of my head, I'm not sure where they are, but they're just really tiny Node.js files. Like they may be like 8 lines or something. And it basically just says, use WasmEdge extensions. Here's the Wasm file on disk. Here's the image, process it, and then tell me what it was. And it was just for my own testing to make it simple. But we've made quite a sophisticated version of that in the function as a service system that we have, where people can actually interact with the Node.js implementation, which performs TensorFlow, but they do it via HTTP. So you can do gets and posts and things like that. So it all via the web. And that was just like another implementation where we sort of put a RESTful API over it, basically, so that if you just had an app and you didn't care at all about what was going on in the back end, you just say, my app uploads a photo, or my user on the website, they just upload a photo and they push a button. And what you have to do as a front-end web developer is you just look at the function as a service system, and there's an ID. So the WebAssembly executable is actually uploaded by anyone, and then it's stored at a position. So the web application, the front end, only has to just call it with a HTTP request and just put in the correct ID, and then the rest happens for you. So it's kind of like this code reuse, which is ideal. But I guess in the real world, it doesn't always happen. But we have a lot of WebAssembly functions up in there that do a lot of cool things like image processing, flipping and rotating and grayscaling and thumbnails and all this sort of stuff. So people can just harness that straight off the bat, just over the web. So I can show you that. It's actually pretty cool.
Yep, that would be great.
Awesome. There's also 2 modes, as sort of quickly. So one of them is that you actually we talked about last call about how sometimes you only need back like a yes or a no, or a, what is the object, like just a piece of text. So in that regard, we have a specific function call that actually returns a string. And then in another one, with the RESTful API, all you do is exactly the same call to the same endpoint, but you put on the end of your call /bytes. And what that does, it will actually return to you a byte array. So what that enables is you can pass up an image and it will perform the TensorFlow functionality, and then it will actually pass you back an image. And what's cool about that is we've done some demos with bounding boxes and labels and things like that. So not only can we actually identify or classify, but we can actually return your original size image with bounding boxes drawn with the labels and things like that. So it's all processed server side. And you can actually do this in Node.js just on the file system as well. I guess the RESTful API layer over the top's sort of irrelevant. It's just an extra feature that we've put on top, some icing on the cake. But yeah, does all that make sense? Yeah.
Yeah, makes sense. Absolutely.
Cool.
So as an action item, I'll just at least get started by creating the issue.
Yeah, perfect. Yeah.
Right.
Yeah. And even more than one, like just split it up so that we can get to it. Yeah.
Sure. All right.
Awesome.
Sorry, I have one more question.
Yeah.
The demo just shown by Huiying Dai, it seems running in standalone scenario. So I'm just wondering if it's possible to embed it with a module back into an application and then integrate with the Kubernetes.
Right. We haven't really explored that a lot, but that's kind of the goal, is to take advantage of these systems where we're able to implement scaling and make this into edge applications for the web specifically. So that would be definitely something that we're doing very soon and demonstrating. Yeah. Heide, have you got any input into that one? So instead of just doing like a standalone demo for demonstration purposes, is actually integrating that?
Yeah, actually, I think that the original demo is show that we want to use something like a Docker, to manage your container, and then the Kubernetes part is I think it's something like a plugin, just build from scratch. So I think the use case is, for example, the scale or something like that is our next step. Yeah.
Yeah. Just another thing, which is a bit of an aside. Does everybody have access to the chat window at all? If I paste in a link, there's a demo, which I think's pretty awesome. It's github.com/second-state, and then it's /DAPR-WASM, so Dapper WASM. There's a live demo there. So we've done a video and a tutorial article, and that's all set up. It's actually really interesting, this portable event-driven runtime scenario where we actually have processes that are being called. So once you set this all up and you launch it, you essentially have, like, for want of a better word, like listeners, and they perform a whole bunch of different tasks. So you're sort of registering like WebAssembly functions on the system, and then the application can call them. And to me, that's really exciting. That's really interesting. We have different examples in Rust and Golang, and so if you wanted to check that out, it's a pretty good demo. And there's, like I say, there's a video and written documentation and a tutorial and things like that. So it's really integrating it into how would you build like services for web applications using this type of new technology. I read somewhere the other day that it was bleeding edge instead of cutting edge, and I guess that's true because, you know, it's very experimental. A lot of the things that you go and chase down, you'll see that they're very new, and there's only like a half a dozen examples, or a few people that actually really have completed that. So yeah, no, it's interesting, and it's a real paradigm shift in terms of, I mean, the Jamstack thing that we've been talking about in recent times is another one. It's really interesting, and just having the markup and JavaScript and these function as a service type approach.
Yeah, thank you very much.
Cool. So if you have any questions after this, of course, or if you're watching this post the meeting, yeah, feel free to just utilize the GitHub, because we're all in there all the time, and there's a lot happening in there. Okay, well, thanks everyone for joining us, and love to see you back again. And yeah, please, come along into the GitHub and start collaborating with us. And if you have any applications of this that you want to use this in the real world, we'd be very happy to help. So thank you so much for joining, and we'll see you again next time.
Thank you.
Thanks so much.